Hey everyone, it's Berm, and this is Level 0 Networking. In our first video, we did a basic multi-point VPN solution using ZeroTier. While that's a great solution, sometimes we need to have more than one tenant, and sometimes we want to do micro-segmentation. ZeroTier builds an emulated LAN for all your nodes. You can run anything you can run over normal Ethernet networks. So using this means we can achieve multi-tenancy or micro-segmentation with MPLS. That's right, this video is going to be ZeroPath with MPLS. Our setup for this is going to be about the same as it was in video 1, however we're going to be adding a second hub. We are going to be skipping the installation and the setup of ZeroTier. If you want to see that, go check out the first video, or go check out video 1.5 where we do the installation there. A note about hubs. In DMVPN, the hub served not just as a way for spokes to know how to get to each other, but also served as a critical routing component in the hub and spoke technology. Traffic would need to originally traverse the hub, always, and if a spoke-to-spoke connection cannot be established, traffic would always traverse the hub. In this design, the hub is really just serving routes, which is why we're going to be doing a BGP listener. You could put it in the cloud and fully support an entirely on-premise solution. In this lab, we're going to use 3 VRFs. Use as many as you need or as many as you'd like for your lab. As you can see, on the left and right of the spokes, we have our key. So spoke 1 is going to be site code 11. Spoke 2 is going to be site code 12. The VRFs get mapped to a routing table in Linux, which is what the numerical value after table is indicating. Let's go ahead and get started. First, let's log in. And now we need to go into configure mode. We're going to be setting VRFs A, B, and C, and they're going to be mapped to table 101, 102, and 103. Next, we're going to be configuring just spoke 1. We're going to be adding the IP addresses to the interfaces and also adding the VRFs. As you can see here for Ethernet 1 VIF10, we're using 10.11.1.1. Again, this is in line with the site code. Underneath, you can see that we've also added the VRF command, so VRF A, B, and C, to the interfaces. We'll go ahead and do the same for spoke 2. Again, spoke 2, we have 10.12.1.1, VRFA, same as on the other side. Now that I've set these interfaces, I'm going to go ahead and commit and save the configuration. I'm just going to exit real quick so I can change the screen width. We're going to go ahead and configure BGP now. These commands are going to be for all 3 VRFs. They're used to populate the VPN v4 tables at our sites. If you'd like more information on what exactly they're doing, check out our blog post about L3 VPNs. That link will be in the description below. First thing we're going to do is we're going to set the import and export to VPN. Then we're going to do label VPN export auto. Now we're going to set the route distinguisher. We're going to redistribute connected, and we're also going to go ahead and set the route target. Finally, we're going to set the BGP system AS to 65,000. This AS number is going to be the same for all the devices since we're using iBGP. I'm going to go ahead and do the same commands, however we're going to be doing them for VRF B and C. You'll notice the key difference between these VRFs is going to be the route distinguisher and the route target. Like we just did on the spokes, we need to set our VRFs on the hub as well. Without these commands, none of the VRF traffic will work. First, we'll map the VRF name to a table in Linux, and then we're going to set the VRF inside the protocol BGP. Again, these commands are identical to what we just did on the spoke. We're going to do this for all 3 VRFs. Our 2 hubs are going to be VPN v4 route reflectors for this solution. The hubs are going to peer together to make a route reflector cluster, and both serve as route reflectors for the spokes. For this, we're going to need a loopback to build our VPN v4 adjacencies to. In VyOS, these are called dummy interfaces. So let's go ahead and do that now. On hub 1, we're going to make our address 10.0.0.1. We'll go over to hub 2. On hub 2, we'll make our address 10.0.0.2. As I stated previously, we're going to be using the AS of 65,000 for all of the devices because we're using iBGP. So we'll set that now. We're going to be setting up a BGP listener and a route reflector on both of the hubs. So we'll go ahead and do that now as well. As you can see, we have the BGP listen range of 10.13.0.0. That's going to be our range for this lab. We also put the remote AS of 65,000, and we're adding the route reflector command. Those commands were for the zero-tier peerings. The next set of commands are going to be for the VPN v4 peers. So we'll go ahead and add these commands now. As you can see in here, we're adding the update source command of the dummy interface. So that's going to be for the two hubs to peer together. These next commands are going to create a prefix list for the zero-tier LAN prefix. The reason we're doing this is so that the route reflectors don't receive multiple copies of these routes. Now we're going to redistribute connected, and we're also going to apply that route map. Now on hub 1, we'll go ahead and manually assign our neighbors, and that neighbor is going to be hub 2. Again, as you can see with the neighbor 10.0.0.2, we make sure to put the update source of dum0, which is again the loopback address. Now we're going to do the same thing on hub 2, except we're going to point it at hub 1. These last two commands are going to be for utilizing MPLS over the zero-tier address, which we use Ethernet 10 for. Now that we're back on the spokes, we're going to set up more dummy addresses. So for spoke 1, we're going to do 10.0.0.11. And on spoke 2, we're going to do .12. Now we're going to input the same prefix list for the 10.13 or the zero-tier LAN. And this is going to be the same policy map. Again, we're doing that so that we don't receive the route multiple times. As we did on the hub with the spokes, we're going to need to set up the BGP neighbors. Again, we're going to redistribute connected, and we're going to have the route map for the deny. Then we're going to set up the peerings to the hub. These commands are the same as they were on the hubs, except now we're on the spoke. Also, this configuration will be the same for all the spokes, no matter how many you have. We didn't do it, however, this config can be cleaned up by using a peer group instead. Now we'll set Ethernet 10 up to utilize MPLS. And finally, we're going to commit and save these configs. Well, now that our config is done, let's go ahead and do some verification. First, we're going to check BGP. To do this, we're going to do show IP BGP sum. All right, this looks good. So the stars are going to designate that it's a dynamic neighbor, as you can see from the screen. We can see that we're receiving 3 prefixes from 10.0.0.11 and .12. We're also receiving 6 prefixes from the other hub. Next, we'll head over to spoke 1, and we're going to check VPN v4 over there to make sure route reflection is working. So again, we do show BGP IPv4 VPN. Now before we configure our customer edge connections, let's go ahead and verify that we can ping the gateways between the spokes. So we'll ping the VRFA gateway. And that's a lot of nothing. All right, let's make sure that the routes made it into the VRF. So to do that, we're going to do show IP route VRFA. As you can see, we have the routes. Next step, let's check MPLS. So it's going to be show MPLS table. The labels look fine. Lastly, we can check that we have the destination prefix in the fib. To do this, we're going to need to go into the shell. We'll drop down into the shell. We're going to run IP route show table 101, and then we're going to grep for the network. As we can see, we do have it there. Now, I did all this to show you what could go wrong. ZeroTier has its own rules engine for traffic, and by default, the only traffic allowed is ARP, IPv4, and IPv6. So to fix this, we're going to need to go look at the rules under the network section in ZeroTier Central. All right, over on ZeroTier Central, we need to go to the flow rules section. As you can see here, we have drop, not ether type IPv4, not ether type ARP, not ether type IPv6. MPLS is ether type 0x8847. So we're going to need to add that under the IPv6 portion. And we'll save those changes. Back on spoke 1, now that we've set the ZeroTier flow rules, we'll go ahead and test our ping one more time. As you can see, the ping test is now working. The last thing we're going to be doing in this lab is setting up our customer edge BGP peerings. That's going to allow our customer edges to talk to each other. For this, I'm using 2 Cisco routers. You can use any device you want as long as it's able to do eBGP. On spoke 1, we're going to go ahead and set up the BGP neighbor. So let's go into configure. And then we'll put in our neighbor commands. Our CE is going to be 10.11.1.2 on spoke 1. Again, that goes with our site code. As you can see here, the remote AS is 65011. Again, that's because it's simulating a customer edge. So it's going to be eBGP rather than iBGP. On spoke 2, we'll be doing the same thing. Again, we have 65012 because of eBGP. you'll notice that it's actually a different AS than even the CE connected to Spoke 1. And again, that's because they're two separate customers. Let's go ahead and commit and save on both. Now, on customer 1, we'll go ahead and set up our interface. For this, we're going to use 0.0.10. First, let's go into config mode. You can see we did the IP address of 10.11.1.2. That's because Spoke 1 is 10.11.1.1. We're doing router BGP 65011, which is what we just configured on Spoke 1 to be the peer. And we're going to redistribute connected. As you can see, the adjacency came up. Now, we'll go ahead and do the same for customer 2. As you can see, we did router BGP 65012, and we did the IP address of 10.12.1.2. Again, that's because of the site code for site 2. As you can see, the adjacency came up again. Now, over on customer 1, we'll go ahead and show IP BGP. So let's end and show IP BGP. As you can see, we do have the 10.12.1 neighbor. So we should be able to ping the other customer site. And success. Well, I think this is a pretty amazing example of what we can do with Linux routing and with ZeroTier. And there are so many other things that can be done with VyOS. In the next part of the series, we will look at how to easily increase the scalability of this design if you have a massive network using regionalized designs. You guys make sure you check out the blog. Again, if you have any questions about the commands, we're going to have the blog link in the description below. Make sure you click on the link, check it out. If you haven't already, make sure you like and subscribe for more content, and we hope you enjoy the video.